Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for finding the number of bits set in a positive integer. Let's look at the problem description. We are given a positive integer n and we have to write a function that returns a number of bits set in its binary representation. Let's take a look at the example 1. So we are given an integer number 11 and the expected output is 3. So the binary representation of 11 is 1011. So there are 3 bits set, so we have to return 3. And for the example 3, for this input there are 30 bits set in that binary representation, so we have to return 30. The constraints are the value of the number is ranging from 1 to 2 to the power 31 minus 1. Let's look at the approach to solve this problem. So we are given the input number 11 and the expected output is 3 because the binary representation of that number has 3 bits set. Basically we can do bit manipulation on this number to find the number of bits set in that number. Okay. So first we initialize the count variable to 0 and then we check each time we check whether the most significant bit is set by ANDing 1 with the input number. If that is not equal to 0, then that means the least significant bit is set, so we increment the counter. Then we do the right shift once, so this number becomes 101. Again we check the least significant bit of the new number, so second iteration also the number is set, and the third one it is not set, and fourth one it is set. So each time whenever the bit is set, we increment the counter and finally we return that counter. That's what I have written here. First initialize the count to 0 and right shift the input number 1 bit at a time until it becomes 0, and in each iteration we increment the counter. Let's look at the flowchart. Input for this procedure is number integer n. First we initialize the count to 0. Then we check whether the given input number is greater than 0. If it is less than or equal to 0, then we return the count. And if it is greater than 0, then we check whether the least significant bit is set for that number. Okay, by ANDing number 1 with the integer n. If that is set, then we increment the count. Otherwise, we skip that. Then we do the right shift operation on that integer once. Okay, then we repeat that process until the number n is 0. And finally, we come out of the loop and return the count. Let's move on to coding. First, I initialize the count variable to 0. Then I write the for loop. This runs until n becomes 0. First, I check whether the least significant bit in that number is set by ANDing 1 with that number. If it is set, then I increment the count. Then I do right shifting operation on that number once. And finally I return the count. Next I'm going to run the test cases. All the tests passed. Next I'm going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. Let's do the code walkthrough for this input. So the given input integer is number 11. So the binary representation is 1011. First we initialize the count variable to 0. Then we enter the for loop. This will run until n becomes 0. First we check whether n is greater than 0. Yes, it is. So we enter and then we check whether the least significant bit is set for that number. In this case, this number is set. So we increment the count. So when we leave that iteration, the count is 1. And then we do the right shift operation once on that number. So that number becomes 101, which is 5. Okay. In the iteration 1, we check whether the least significant bit is set or not. In this case it is set, so we increment the count. So the count becomes 2 and then we do the right shift operation once. So this number becomes 2. So the n becomes 2. Then in the iteration 2, we check whether n is greater than 0. Yes, it is. And we check whether the least significant bit is set. In this case it is not set, so the count remains 2 and we do the right shift operation on this number once, so the number becomes 1. Then in the iteration 3, we check whether the least significant bit is set. So it is set, so we increment the count, so it becomes 3 and then we do the right shift operation, so the number becomes 0. Okay, so finally we return the count, which is 3. That is an expected output. Next I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis on this solution. First we take the case 1 where the input number is 1. So for this number, how many times this operation is done? So only one iteration. So for the first iteration, n is greater than 0, so we check whether the least significant bit is set or not. We increment the count. Then when we do right shift, n becomes 0. So this for loop performs only one iteration. But in the case of number 15, we have 1011. This for loop performs 4 iteration because it has to process all the 4 bits to count the number of bits set in that number. Okay, so if there are n bits in the input number, then this loop performs n iteration. So the time complexity is order of n. And with respect to space complexity, we are not allocating any additional space. So the space complexity is order of 1. Thanks for watching this video. Have a great day.